All right, this is the moment where we rebuild this from scratch. So the idea of this example here is that we can select particular stocks, and then based on that selection, it will compute which stocks are most highly correlated to that particular selection. So let's go into a new workbook and start rebuilding this. So the first thing that we need is we need to have two measures to correlate. The first measure is going to be the stock close value of every single stock. And then the second measure is going to be the stock close value of our reference stock. And we want that for every single day to compare against all other stocks. So if we just look here at our different stocks and the close value of them, let's say, we want to pick a particular reference one. So any one of these really, right? So we need to capture that reference stock somewhere. And so we can capture that in a set. So this will be our reference stock. And let's just pick Abercrombie & Fitch just to have one in there. And so now we need to return the close value for our reference stock so that we have it as a separate measure. So we can conditionally return that in a calculation where we say if stock is in our reference stock set, then return the close value, and otherwise don't. And so this will be now our close for the reference stock. And so if we bring this into the view, then you will see that it's kind of pulled out that one value for Abercrombie & Fitch here, but it's only existing in this single row for Abercrombie & Fitch, but we need to be able to compare it against all of the other stocks, and so somehow we need to copy that value across the other rows. And so I'm going to just, for performance reasons, just because it takes long to render all the data in a visualization while it doesn't to compute it on underlying data. So just restrict this for illustration purposes. So what we want to do, if I bring in the date field here, is take the daily close value for Abercrombie & Fitch and then copy it across all of the other stocks so that we can, on a row-by-row basis, compare each stock against our reference stock. And so the way that we can do that is we essentially want to aggregate this number up to the day level. So if we take a maximum of this number here per day, that will just give us the value of Abercrombie & Fitch because it's null everywhere else. So in calcs, how you express that is you say fix to the day level the maximum of the close for the reference stock. So this now gives us our daily comparison. And so if we then grab that and take this, you'll see it's now copying that number across all of the rows. So we can now compare on a row by row basis this value for this value to this value and correlate them. So then we can do our correlation function between the close value and then our daily comparison. And if we remove the date, and then it's computing on the underlying record. So it's giving us that correlation is actually an aggregation. It's computing the correlation on the underlying 600 and some records per stock based on the 2-year time period here. So let's remove, we don't need that anymore. And so that's now returning a correlation between these two values per day, across all the days per stock. And so these numbers here are the things that we're going to want to filter on. So we're going to want to keep the stocks where this correlation coefficient is, over 0.95 or under negative 0.95. And so at the moment, these numbers are just being dynamically computed within this sheet. based on the fact that we happen to have the stock name as our level of detail of this sheet. But if we want to use it elsewhere where the level of detail is different, we're going to need to store that number in a reusable manner. And so we can do that by fixing that aggregation to the name. So if we fix to the name this aggregation here, this is now going to give us our correlation per stock. And so you can check this should give you exactly the same number as what the dynamic aggregation gives you. If it doesn't, something's gone super wrong. The difference here is that this aggregation is just doing the group by based on whatever you have in the viz. So if I add another level of detail like the stock year, this one is recomputing to group the correlation per year per stock, whereas this one is not. It's fixed to the stock name. And that is what you want when you start to try and filter based on that specific number in other views that are going to be at the day level of detail. So now we can use that correlation per stock to create our filter. And specifically, our filter is going to be driven off of a parameter where the parameter is our threshold, essentially. And so let's say we give this a range between 0 and 1. And let's give it a step size of 0.1. And so in this case, we want the absolute value, because we're happy to consider a negative correlation as well, to exceed our threshold. And so that becomes now the filter. And so if we drop this onto our filter shelf, and then we grab the date, and we look at, oh, I think my threshold is just super high, so let's do something where we actually have some numbers. And then we can look at our close value across the different stocks. And so now you can see there's Abercrombie & Fitch, and it's found 2 others that are highly correlated to it. And as we decrease this, it starts to add in more other ones that are quite similar to it. So that is the crux of the sort of statistical computation complete, right? We've now successfully managed to compute stocks that are similar to a reference stock. So the remaining pieces here are now updating this set dynamically based on selection, and then making this viz trellised so that it accounts for the fact that the axes are so variable across different stocks, and you can't necessarily compare them all on a single axis. So let's go and make that other view where we can select a particular stock based on its average change value, right? So we could do something like this. I think I had it as a circle. Heat map doesn't really matter, right? And if you wanted to just make this, whether it's positive or negative, well, we could do that too. All right, so we have our indicators of what's growing and what's decreasing. And so then we can bring these two together in a dashboard. So let's go and make this one a drop down. And just kind of hide some of this stuff here. And stick this one up here. All right. So we've got our dashboard more or less in order here. And so now we need to be able to dynamically change our reference points. If I click on one of these, I want it to re-baseline and compare against that selection. So we can do that through the set action. So we'll change our set values here. And from, these are such well-named sheets. So from sheet 3, I'm going to update this reference stock. And I'm going to do the same from sheet 2, but I want to do a different thing when I clear the values. Specifically, in this case, I want to keep the set values just because when you're selecting in the viz itself, it tends to highlight the point that you selected and you need to clear it in order to remove the highlighting and see the impact of your selection. So now if we go and pick this one here, it's now changing everything against that particular stock and finding things that are highly correlated with that stock. Or we could, again, search a specific stock. That one's quite cool. So yes, in the next video, we're going to go through and look at how we can make this mess here a lot easier to understand and a lot more beautiful, even if you have lots of data. So that will be up next.